All right, thank you. Show of hands, how many of you are running an instance of the open source version of Canvas? A few of you. How many are running it in production? A few of you. Okay, great. Well, you'll get something out of this then. So, brief overview. We're going to talk a little bit about Ruby and Rails, intro to Canvas, how we scaled it up, how we integrated it, where we're at now, and then give you some references at the end for our code and that sort of stuff. So, first, know thy source. Canvas is written in Ruby on Rails, so we needed to know a little bit about the language. Well, it's a scripting language, so are Perl and PHP and Python. Maybe you found those pretty easy. I did, so Ruby should be too, right? Well, wrong. Ruby is an object-oriented language from the start, but it's got lots of shorthand syntax, like this stuff up here. Metaprogramming is strongly encouraged. That includes things like modifying built-in classes to add functionality. So this code here turns the number 2 into a time value. And this is really cool from a programming perspective, but it's really difficult to understand from a debugging perspective because you've got all this functionality being inserted at all different places. What this boils down to is for scripters, Ruby's object-orientedness is kind of hard to wrap your head around. And for traditional Java object-oriented developers, Ruby's shorthand syntax is hard to wrap your head around. So this all results in a rather steep learning curve. Rails is a web development framework. It's implemented as 3 separate Ruby modules that adds extensive functionality to Ruby. Imposes its will. You can do it our way or, well, just do it our way. It's essentially another language to learn on top of Ruby, and this is quite common in the Ruby landscape. But there's more to it than that. Maybe you've read the Rails books, which all say you don't need to know Ruby. I don't know why, but they lie. You've learned some Ruby. You think you're done. Well, you won't get very far, because on top of all that, there's all these other things you've got to learn. And not all of these are used by Canvas, but almost all of them are. So it's good to know these technologies if you're going to go on your own and run this stuff. So you'll get a headache. But why would you want to do this? Well, Ruby on Rails is a cool language to work in. It's got a short development cycle. You can produce cool apps in a week. It's got decent built-in security. It's fun to code in. And this convention over configuration, this do it our way, means you've got predictable behavior. You just have to understand that behavior because you're not going to see it in the code. It's going to happen in the background. All right, great. So let's run Canvas. Now what? Hire some Rails developers. Yeah, good luck with that. They're not so easy to find. Train some Rails developers. Fire up Canvas. Wait a minute, why is this app so slow? Scale Canvas up. All right, so before we get into Canvas specifically, we'll just give you an overview of what a Rails app looks like. There's a database server. It's typically treated more or less as a black box. The app server is where the actual Rails application source code lives. On top of that, you'll have an Apache or Nginx or something like that web server, and then some sort of app manager plugin that lives between the two of them, such as Fusion Passenger. This handles starting and stopping the Ruby processes and proxies requests from the web server to the app. You'll probably have a cache server to cache fragments of HTML. It's not needed, but, well, yeah, you'll pretty quickly figure out it actually is needed. And if you have more than one app server, then you need some sort of shared file space that all the app servers can access. You can do this in the database, but don't, because it's not going to scale. The app itself is single-threaded, which is quite different from the Java world. One HTTP request at a time can be processed by your Ruby process, which means if you want to handle multiple HTTP requests in parallel, which most people do, you're going to need a pool of multiple Ruby processes. So what that means is a relatively low memory footprint compared to Java, but high CPU usage, at least per process, in our load testing at least. This is quite different from our Java world where we have very low CPU usage, but huge amounts of memory usage. And so this was kind of difficult for our VM administrators to wrap their heads around. Typical Rails architecture looks like this. You've got the database server at the bottom, maybe a couple of app servers, and a load balancer to spread requests between them. As you scale up, you can add your app servers, and as you scale really up, you can keep adding app servers, but you've still just got that one database server at the bottom. So if you run a database capacity, add more database capacity, more CPUs, more memory, fast disk. If you can't, then it gets complicated. But in our testing so far with Canvas, we haven't had any issues with our database capacity, and we have a relatively modest database server that we have a lot of room to grow with yet. So is that all there is to it? Of course not. There's more best practices for you. Run a syslog server so that all your app servers are logging to a central syslog place, and then run some sort of log analyzer against that to graph your Rails performance and that sort of thing. Take a look at Logstash if you haven't heard of that. If you're working with syslog data or anything like that, Logstash is an awesome log aggregator. Think of it as a free version of Splunk, if any of you have ever heard that. Run a separate cache server. Sessions are not tied to app servers, which means when a user's requests come in, it can be fired at any of your app servers in the pool. So if you have a separate cache server to keep those cached content, then you'll vastly improve your performance. Use the delayed job gem to handle asynchronous processing. Because the Ruby process can only handle one thing at a time, you want to get your asynchronous processes out of the way so that your main Ruby processes can handle your user requests. Run those delayed jobs on a separate app node. And automate your build and deploy, because if you have a whole bunch of app servers there, you're going to need an automatic method of pushing code out to all those different app servers. So let's talk about Canvas. We all know that it's a cool new app. It's only been around for a couple of years now. Instructure's business model is pay us to run it. It's Amazon hosted, and all the source code that runs in Amazon is available on GitHub. But there's a couple of proprietary pieces that haven't been released to GitHub. These include the multi-tenancy support, if you want to run multiple sites on your instance of Canvas, the analytics, and currently the mobile app support. So why would you want to run Canvas yourself? Well, maybe work was boring. Maybe you like a challenge. I personally love a challenge. I personally love a challenge, but that's not why SFU chose to do it. Maybe you have laws that says you must run it yourself. In British Columbia, we have a FIPA law. The FIPA is the Freedom of Information and Protection of Privacy law that says you cannot host personal data outside of the country without the express permission of that user. That means we could not use the hosted version of Canvas. But we loved Canvas so much we decided to run it ourselves. Maybe you want to customize the code. Maybe you don't like somebody else controlling your learning environment. You don't want them to upgrade on their upgrade cycle. You want to upgrade on your own upgrade cycle. Or maybe you're just cheap. So, what does it take to run Canvas in-house? Keep up with their current code. As they've told you, they push new code out every 3 weeks. If you don't, you're in for a world of hurt. Run what they run. Or... That's a guy watching his upgrade blow up in his face. So what does that mean? That means running their database server, which is Postgres. As of Rails 4.0, which is going to be released any day now, they actually have Postgres-specific goodies coded right into Rails. So you can expect over the next probably year to 2 years that MySQL support will diminish. Run their version of Ruby, and run it on their OS, which means some flavor of Linux. Don't try to run it on Mac OS or Windows. Minimize changes to their code. You'll be updating every 3 weeks if you want to keep up, and integrating changes is going to be painful. Implement customizations via plugins. These are Rails plugins or via LTI, but don't use plugins because they're deprecated in Rails 3 and unsupported in Rails 4. Become an agile web startup, or you're done. So what does that mean? That means a continuous build, test, and deploy cycle. Because you're going to be doing this very often, you want it as automated as possible. Ensure your production environment can be cloned quickly and easily to create test dev environments often. Use something like Capistrano to automate the deploy. That's a Ruby gem that allows for automatic deploying of code to multiple machines, takes care of all the SSH, moving things around. It's very slick. And master the ways of things like Git, Rake, Bundler, and Bamboo. Be prepared for some of this, and maybe lots of this, on your way towards that, which is a diagram of our automated build and deploy, our various Git repos and things like that. So very quickly, because I know we're short on time, I'll run through our Canvas experience. Inception to production in 4 months. It was announced last September we were going with Canvas, and by January we had to have something in production. Only 6 courses and a couple of hundred students, but it was production nonetheless. And full production in another 4 months, which was this past May, with 5,000 students, and ramping up to 25,000 students by this coming January. Our deployment cycle looks something like this, zoomed in. The purple bubbles there are when new faculty come online to develop new courses, and the yellow bubbles are when new students come online to start taking those courses. In reality, the purple bubbles did not add much load. The yellow is really where we had significant uptake in the usage of the system. So over the lifetime of this project, you can see the substantial increases where we'll see increased load. We had 4 FTEs assigned to getting this project going. Almost all other work went on hold. Very limited Git experience, no prior Postgres experience, but that didn't stop us from choosing it anyway. Our DBA of 35 years went, that's fine, I'll give it a try. It turned out to be a very wise decision.
You seek Postgres.
Production environment right now is 3 4 CPU app servers and 1 management server. Log analysis and Google Analytics in place. This is very cool because it allows us to see how many users are hitting this and what their usage patterns are like. One of the interesting things is we chose to import the content from our 11,000 legacy WebCT courses. This is something we hired Canvas to do, Instructure to do, their professional web services. But this allows faculty to import their course content from their legacy WebCT courses into their new Canvas courses and allows them to get started a lot quicker. We had our workflow for our three-week update cycle in place, and we'd done load testing for what turned out to be at least an order of magnitude more users than we are actually seeing. And our 3 app server environment was easily able to handle the load. There's a note on our load testing. We're using JMeter scripts. We've got the code actually in our references at the end there if you guys are interested. Sorry, you all are interested. Some of the interesting things for our summer semester deployment, we have an in-house replacement for Google Previewer. Again, because of our FIPA legislation, we couldn't use the Google Previewer to allow people to see documents because that would involve the document getting shipped off to Google to be previewed. So we had to disable that until we had this Google Previewer written. It uses a LibreOffice application wrapped in a Ruby on Rails application to do the Google Preview, but that way the document stays completely within our environment. We have a custom reporting plugin developed, which is a vendor plugin that allows us to see things like number of students enrolled for this term, number of teachers enrolled, things like that. We had just upgraded to Ruby 1.9, which saw a significant performance improvement. And we had page views turned off because we saw that Instructure had some issues with page views last fall, and we didn't want to fall into that trap. So until we fully understood what implications it had, we left it off. That turned out to be a good decision as well because we're going to bring up a Cassandra instance over the summer and do the same sort of infrastructure that Instructure is doing. So some stats. This is real-time from Google Analytics. So we can see we've got like 43 active users right now. Our page views, we're peaking out at around 40 to 50,000 page views a day, or about close to 1 million page views a month. One of the interesting stats here is the breakdown of operating system. We can see here we have about 12% of our users coming in via iOS, another 4% via Android, so about 16% in total via mobile. Compare that to the number of IE users. So we have nearly twice as many people coming in via mobile as via Internet Explorer. Canvas integrations that we've done up at SFU. We're making use of LTI, Rails plugins, and extensive use of the API. This is a screenshot of the document previewer. It just drops in and is an exact replacement for the Google Previewer. Nobody knows that anything is functioning any different. Screenshot of our reporting plugin, so you can see the courses for the current term and the number of enrolled students and teachers and everything. This is something the management absolutely loves. And our portal access. This is actually a snapshot or screenshot of our email system. We use Zimbra in-house. And Zimbra allows you to develop plugins for the web interface. So we've got a tab over there, the MySFU tab, and then a list of students, or a list of courses that this particular student is enrolled in down the left-hand side. And it's called a Zimlet, this plugin, knows that this course is a WebCT course and provides a link to the WebCT course, and that the other course is a Canvas course and provides a link over to there. So the student doesn't even have to know, as we migrate from one system to the other, what learning system their course is hosted in. They can simply go in here, click on the link, and it'll take them there. Whoops. All right. And over to OCAD.
Okay. Hello, everybody. So I gave a presentation last year at InstructureCon about our implementation. So the video for that is on Instructure's Vimeo channel if you want to check that out. So I'm going to talk about some of the integrations that we've done. So when we talk about integrations, you like to think of the sort of the heroes of integration, and that's LTI and API. So if you haven't heard of LTI or API, welcome to InstructureCon. It's going to be great. So I was going to talk a bit more about both of these, but I'm sure you have been inundated with information about both of these tools, so I'm going to skip over that a little bit. Some other ways, some channels for integrating are custom CSS and JavaScript, and also plugins. So when I say plugins, and this is something that would be specific to the open source installation. So Rails itself has a plugin architecture, so if you have a chunk of code, you can stick it into your Rails installation in a sort of isolated area where it's not going to interfere with any of the other Instructure code. So you can put all your stuff in one place, and there's no danger of running into merge conflicts and that kind of thing. So plugins are low level, but they're quite powerful and versatile. And there's also plugins in Canvas itself. So Canvas has a bit of a plugin architecture in certain areas. So there's tools such as the conferencing tool, where you can develop your own plugin, stick it into Canvas, and then you can use your own custom conferencing system. So we developed a conferencing plugin for Adobe Connect, and we contributed it back to Instructure, and now anyone can use it. And there's one other method of customizing or integrating your Canvas installation if you're running open source, and that is to modify the source code. However, this is the path to the dark side. Modifying the source code leads to anger, anger leads to hate, and hate leads to suffering. So, be warned. LTI, you guys know all about this. I don't need to go into this in any more detail. Here's an example of one LTI integration that we've done. So this is a button on the rich text editor. So if I click here. So at OCAD, we have a proprietary image library of something like 90,000 images. These are high-res art history images. We're an art and design school, so this kind of thing is useful for us. So we wanted a way to integrate this content directly into our course content. So one of the other developers at OCAD developed this LTI plugin. So Wi-Fi seems good, so I just have to click on one of these. It plops the image in here along with metadata. So some screenshots of that. API. I'll show you an example of one of our API integrations. So this is sort of our web portal. So we have this little Canvas widget, which pulls the updates and to-do items out of Canvas and sticks it onto the user's. Yeah, so that goes directly there. There's me with the dancers. Yeah. Right. Okay, so LTI and API work really great together. So when you can combine them, you get even greater things happening. So an example of that is how's that? So we wanted to, before we were on Canvas, we were using a custom LMS that we had developed in-house. And our grade submission workflow was really tightly integrated into that LMS, and we wanted to maintain that experience for the faculty. So we wanted to have that grade submission process really easy for them to use and integrated into Canvas. So we're using LTI to create a submit grades navigation item within the course. And then we're using the API to pull the final grades for the course, stick it into this page, and then the instructors can submit it to the dean and blah, blah, blah. So yeah, that was worked really great for us. There was a little bit of the dark side involved in this tool. There was a sort of shortcoming with the API that the final grade that you pull out of the API doesn't include muted assignments. So if you have a muted assignment in your course, that won't be calculated in the final grade. So that was a bit of a problem for us. Our instructors, because of our weird grade policy, our instructors are sometimes reluctant to publish all the grades, which is weird, but so we had to sort of modify the API to include an extra field that revealed the final grade with the muted assignments. So we wouldn't have been able to do that without running the open source version. So yeah, that worked well for us. Let me talk about some pitfalls. One of the challenges we've had with doing this tight integration with LTI tools is authorization. So we have to, because the grade submission tool has its own authorization system, we have to make sure that those two systems, Canvas and the grade tool, are really synchronized in terms of the users who are allowed to access it. So we can't just add an instructor to a course in Canvas because that instructor then won't have access to the grade tool. So it has to all happen one level up. Okay, so custom CSS and JavaScript. You can do it to do custom branding. You can hide certain pieces of content if you want. You can also use JavaScript to stick content into pages. Let me just show you that. So on our, show you the grades page here. So we wanted to have a link to that grade submission tool directly from the Canvas grades page. So we're just using some little custom JavaScript to do that. Okay, plugins. So yeah, I've talked about this sort of low on time, so I don't need to go into too much detail. But there is some cool stuff you can do with Rails plugins. You can add totally new pages into your Rails application. You can extend it as if you were writing the application itself, but do it in a really isolated way where you don't need to worry about merge conflicts. All right, so we just want to really touch on the collaboration between OCAD-U and SFU. When SFU decided to go with Canvas, we were about a year into our decision. We hadn't quite started implementing in production, but we had done a lot of testing already. So SFU brought us out, and we did some consultation and collaboration. And it's been a really great experience. We've shared a lot of stuff back and forth. And if you're considering running open source Canvas, it's a great idea to sort of hook up with someone who might have done it before. All right. And support for Canvas open source has been really great. There's a Google group, which has a fair bit of traffic. I find there's more questions than answers at the moment. But the IRC chat room, all the Canvas developers are hanging out in there all the time, and it's an excellent resource. They're extremely helpful. They're really willing to help you with your problems, and great job for that. Thank you. Yeah, they've expressed a lot of interest in growing the community of open source users. All right, so here's our contact information, and we have links to a lot of code that we have developed. So most of the stuff that we've been developing is all on GitHub, so it's all there for you. And I think that's about it. Oh, thank you. Okay.
So, questions?
Well, I have a question that's maybe not so much for you guys. You explained why you're running the open source version. How about the other folks who raised their hands?
Is anyone running open source that isn't from SFU? Yeah. No.
Yeah.
Yeah.
To customize it for some reason, if you wanted to do something that you couldn't do in the cloud version, like some of the stuff that Fraser had to do for their grades, you couldn't do that in
Other questions? All right, well, thank you very much. We're around if you want to chat.